Alright, so hello everybody. Welcome to another stream. How are we doing? So, last stream we finished up on the occlusion buffer. So we've got this occlusion buffer which is filled in with the depth buffer from the previous frame, and we also have some rough occluders as well, which we can render if we don't have this information available. So it's quite nice. So this helps with performance and allows us to only render the spheres which are kind of on the surface facing the camera, but it does render some of them behind because it's just not perfect. It's got some bugs. It's because we don't actually reproject the depth at the moment. So when you move, you will see some flickering. When you move too fast to the left and right and all this, it will yeah, we don't actually reproject the depth at the moment, so it does have slight issues. But we're not concerned about this. As you can tell though, with the spheres, they kind of flicker a bit. And I'm thinking it's something to do with the rendering code, the anti-aliasing, I think. Yeah, because you're seeing it. If I get a screenshot, I'll be able to go over the exact problem. So yeah, there's another problem with the culling, is it will cull whole clusters like this when they go near the end of the screen. So we've got to fix that. So as you can tell, the occlusion culling is allowing us to render stuff that's like near the surface, because you're seeing the stuff in the middle completely gone when you're seeing this sort of edge here. But whole clusters are getting culled a bit invalid when they go near the end. So that needs to be fixed at some point. But the thing that I'm most fussed about now, like, is that I want to improve the rendering of the actual spheres, because this thing can help improve quality of rendering to how it's supposed to be, and performance as well. So it ticks two boxes. So we'll be doing that today. We're going to be improving the rendering and the speed. So if we open up this in Krita, effectively we anti-alias when we ray trace. So what you'll be seeing is these black areas, these black pixels here. These are basically glitches that you're seeing, and this is what's creating the sort of fizz looking, like, you know, little flickering, right? So these black things are appearing. So we're gonna get rid of that today as well. So it's gonna be pretty good. I want to start off with the re-enabling the profiling, because we are going to be improving that. So I guess if you put the sphere here, we're looking about 2 milliseconds. It's not as jumpy today. But yeah, to ray trace the spheres, it's about 2 milliseconds. Not as jumpy today though. So I guess we'll talk into a little bit on. But yeah, there's all this other stuff as well. It should be accounted for inside the performance stuff. But yeah, for the rendering. But yeah, I think. Yeah, right. So effectively, the way we render the spheres at the moment is we bin spheres into screen tiles. So here's the screen, and we'll bin each tile has an array. So it's actually just one big old array at the moment, and it's still going to be this way, one big old array. But what happens is each tile gets a sub portion of this big array and has another array in here in a sense, right? This is where it puts all the spheres in, right? So then these can be different sizes. Right, so this tile here has more spheres, right? So we have this system already, but it isn't perfect. It isn't great. And we'll hop into the code. So it's called like prepare clusters for render. This does the LOD selection, or prepare clusters at LOD, prepare clusters. So the whole job of this shader is it runs over, you see it run for as many times as we have levels of detail. There's like 7 of them. And it starts off at LOD 0 and sees if any of the clusters we have at LOD 0 can be rendered. And if they can't, it will, if the clusters can't be rendered at all, it won't even bother trying to process them further because maybe it's occlusion cold, or maybe it's off the screen or something like this. I still need to put that one in actually. But then if it's the right size to be rendered, there's an if statement in here somewhere. Yeah, if it has spheres and it's the right size to be rendered on the screen, we then add it to an array of clusters to render. So it goes ahead and marks that this cluster is one we want to render, and so it selected the correct LOD for that cluster. But if that fails, it goes and pushes the children nodes of that cluster onto the ring buffer and processes the next level of detail in the next dispatch here. And it just keeps doing that until it's found all the clusters and added the ones to render to this array. But right now we do this really silly thing where we basically we go over all of the tiles that this cluster overlaps with. So here's a cluster filled with spheres, and we go over all of the screen tiles that it affects, and we say, hey, all of you guys are gonna your capacity for spheres at most will be how many spheres we have in this cluster, and obviously all the other clusters that that overlap that area. But then we do another pass, which is called tile bin allocate. So that actually sub-allocate in this array here, right? The different tiles and their memory. And then we do another pass where we actually fill in these arrays with spheres, right? We fill in those arrays with spheres. And they might not fill up the whole area because you said at most this would have, maybe this is 64 spheres. At most, all of these tiles will get 64 spheres in them. But the way the clusters work is they go over like this, right? Spheres. So actually all of those tiles will not get 64 spheres. They'll just be shared out evenly, kinda. So there'll be wasted room in those pre-allocated arrays, and it sucks because we over-allocate so much memory, and it's a waste. Not to mention these atomic adds as well, probably. So the way we're going to solve this problem is we're going to effectively we're going to replace this tile bin alloc shader and this yeah, with another with a different shader, and instead its job is to fill one big array. And the tile bin shader actually. Yeah, these will go. These are gonna go. And the job of this new shader is to fill the array. It's gonna have 2 arrays now. one array is going to be filled with keys, and the key in the high bits is going to have a tile index, and in the low bits will be the depth. This is the sort key array. And then every sphere gets added into here. This will be a sphere index. There'll be a sphere index array, and you'll fill these with the sphere indices. These will be filled with sort keys, which will again have the tile index and the depth. So the beauty of this system is we get to use that new sort function. And we can fill up this array. A sphere would have to be put in multiple times, depending on how many tiles it actually goes in. But then we call a sort function on this array, and we sort it by tile index and depth second, right? So then that will mean this whole array, both these arrays get completely sorted, and then the tiles, all of the spheres that belong to a certain tile will be contiguous in memory, and they'll be sorted from front to back in depth as well. So that will be really useful when we ray trace against them. We can early out and do proper anti-aliasing. So this might be the hard line between the tiles, if you will, and then there'll be some more spheres. And then another tile border, and then there'll be more spheres. So this is the plan that we're going to execute on. It's going to be a bit tricky in some cases, but I think it's possible to do it today. So we're going to start by deleting stuff. Tile bin. Well, let's not delete it. Let's just comment it out, because you never know. We might want to steal some portions of this. Now the next thing we're going to do is I think we'll call it prepare spheres. I think we should change that name eventually. Prepare clusters and prepare spheres, but it's consistent though. And we can then change that to something else that's consistent and better. So prepare spheres is going to take in as input this clusters to render, right, array. So this will be read only. There's no process buffer anymore. What else? Occlusion texture, because we want to do an occlusion test. What about okay, those screen tiles need to go. What was that ray tracer tile thing anyway? Right. Yeah, this is something we need to sort out. We'll probably have a range like that. Okay. Excellent. So let's go ahead and start creating the shader then. So we'll go to that prepare clusters thing. We'll take its start code probably, because it'll probably be quite useful. Just have all of this. Oh. Alright, so drop this in here. So we're going to get per thread group, we're going to get a cluster, and we're going to pull that cluster out of the buffer. So we're then going to process the 4x4x4 set of spheres on each thread within the thread group. So it's going to be split across two wave 32s. But yeah, that'd be cool. So basically, we're going to get. It's going to be a dispatch indirect. That's for sure. But yeah, we'll sort that out when we go to dispatch it. So the dispatch group index, if that is greater than clusters. Yeah, I think we're gonna set this value up. Yeah, we'll use that same variable, I think. So if it goes out bounds of the array. Actually, how do we do it at the moment? Does tile bin allocate when it? Oh, it goes over all the bins. And then clusters to render count. Yeah, this has already got dispatch and direct on it. Here. Sphere ray tracer bin args. Yeah, it's already got it. Right, that's setting this binning thing. Yeah, I think we can set it in some other shader. But we'll set this up in a bit. So the idea is we're going to get an array of volume clusters to render. That's the thing. Good. So the cluster to render index, I guess, would be. Oh, for crying out loud, I grabbed the wrong damn. Edited the wrong shader. Give me a second. Right. Prepare clusters, prepare spheres. Alright. So each thread group gets a cluster. If that cluster index goes out of bounds, well, that should never happen, but I guess it's a good safeguard. That should never happen. Good safeguard though. Should be fine. Clusters to render. Yeah, there's a question to answer about if this array gets filled up. Maybe. But we'll think about that as well. You get this cluster instance, get the volume instance, then get the volume, then get the node. Now we want to process all the spheres. So I believe that's in that tile bin. We do it in here. There's a tile bin bit set. You do a 4x4x4 exit. So I think I just take some of this code here. Count out screen bounds and occlusion. I think this is all basically it, which is great. Right. Then that goes over all the. Yeah, I think that's basically all the code we need. So let's go over this code as well and explain that. Right. So the idea is we get the bit set for the spheres. If the sphere is not set, where's this cluster sphere index? We need that. So each thread has a sphere. If the sphere is not non-existent, we return early. Then we get the LOD of the cluster, the position in cluster LOD space, some dimensions of the LOD of the cluster in the LOD. And what are we trying to do with this? We've got a view from local. This could probably be pre-computed as well, definitely. Hey, Sleepy Mushroom, how's it going? Then we calculate the bottom left in local space for the cluster. And then from here, we can calculate where the sphere is, basically, in local space. And then we can move that into view space. And then when it's in view space, near clip plane distance, right? Yeah, but then we can use it to calculate the bounding box in screen space. Yeah, definitely needs to clean up past this, but this should be fine. This wasn't in it though. I'm good. Trying to figure out how to figure out this view projection matrix. Awesome. Yeah, what you want is if you name it like we've done, it'll be like far easier. So here's an example. This is a view from local matrix, right? Transform matrix. So the volume instance in this case has a world from local. So how do I take my volume instance from the local space, right, this local space position, into a position that is relative from the world space, right? How do I do that? That's what that matrix does. Then you have another matrix which is basically the camera one, and this is labeled view from world. So it tells you how to take something from a world position into view space. So then you can combine the matrices by lining these boys up, right? That one on the left and that one on the right, and they can join. You can get rid of those, and you end up with a view from local. So I recommend naming stuff like this, and then it'll be a bit easier to understand what matrices you're actually talking about, and when you multiply them and multiply them with a vector or something, you can't be confused, right? This one takes something from local space into view space, so the thing it has to be multiplied with is some coordinate in local space, right? The thing I got it set up, just updating it is the problem. Player position. Yeah. Hmm. Yeah. Have you got multiple things rendering as well? Because I remember VMT was saying that. And that's correct. If you don't have multiple things rendering, it's you can't tell it's just the camera moving or the player. Nice. You have, sweet. Right. So now what do we need to do? We need those arrays that I was talking about. They're two U32 arrays. One is the sort keys. So one is a U32 of spheres to render sort keys to render, spheres to render. There you go. Okay, so these two lovelies as well. So the whole idea is we need to find some place where I can... Oh yeah, off stream, by the way, I had to fix Windows, and I used to have some of my dispatch indirect arguments inside this graphics globals thing. I've now moved it into this GFX indirect args. So we've got a dedicated buffer now for all the indirect arguments. And And this is so I could do the synchronization code correct. And probably more optimized as well. It's just better, it's just nicer. So we have one indirect args thing. So when we create our buffers, might be incorrect here actually. But yeah, when we create the buffer, only if it's marked as indirect does it get this buffer flag usage of this now, which is great. And now when we do a dispatch indirect, we actually have the correct pipeline stage. You need to have these two stages on when you do your sync code, which I was missing, so it's creating a problem on the Windows driver. So I managed to fix that, which is great. And I was missing this as well. So we wasn't putting this access indirect command read on the buffer which had the indirect arguments in, and it was failing to run some of the shaders, unfortunately. So yeah, I've fixed that now, which is great. Hey Egotist, how's it going? Welcome, welcome. How you been? How you been? Yeah, so indirect args are now in here, which is nice. So I like that a lot. So we need to add a new thing, which is like volume spheres to render. So that needs to be cleared to 0. We need to sort that out. But basically, so this goes over all of those tiles. And it calculates a tile index. This is what we want, right? Then we want an insert index. So we get that using graphics global with that new variable we just made. Spheres count to render. Sorry, volume spheres to render count. We up this by 1. Very terrible way of doing it. But we'll correct that in just a minute. Just want to get the initial code in. Then you insert in the volume spheres to render the indice. Whatever your sphere index is, where is it? Oh shoot. We need another array. So this would just be a volume sphere or something. Okay. So the indices will go in here. You need to put the sphere in there. We need an insert index though. So we need 2 different counts. One is going to be the number of Essentially this is tile binned. Tile spheres maybe. Sort keys, indices. Tile binned sort keys, tile binned indices. That's what we'll roll with. Volume spheres, tile binned entries count. Good one. That'd be good. So if we roll with that, your binned entries count, and then tile binned sort keys and indices. Excellent. I'm doing well. How's everything going? Yeah, not doing bad. Not doing bad. Doing pretty good. We got the occlusion culling working now, which is great. Super happy about that. So it's now not got any glitches where it's flickering, but it is flickering here because we've got some anti-aliasing issues. So we're going to be fixing this today. We're improving the rendering on how we ray trace these guys and hopefully improve performance as well. So it's about 2.5 ms to ray trace against here, and the tile binning is kind of like that. So it's about 5 milliseconds to render these spheres. So hopefully we can, yes, it's 2 milliseconds on the ray tracer and then 5 milliseconds in total. Hopefully we can improve that today. That's the aim. And improve the quality as well. Hey, Becky, how's it going? Make the font a little bigger. I've already got it zoomed in by 2 times. Like, I guess just, get a laptop out or a desktop if you're going to be on your phone. Yeah. Like, if I make it, it's just too big otherwise. Too much real estate taken up. So the sort keys, right? So this would be where I like sphere index, we'll call it, okay? Right. So we put the sphere index in here, and we're binning it in this array for every tile that it goes in. So we've got to put a sort key in here though, right? So the sort key. So I'm thinking of making it so you can only have. I was thinking about this off stream. I've got to remember. So I was thinking maybe, yeah, 60 by 60 tiles. Because if we did 60 by 60 tiles, is that enough? Basically, we need as many bits as we can for depth. So is 60 by 60 enough? So we made our tile size 32 pixels squared. Then that means 60 by 60, so 3,600. That takes, it takes 12 bits. So I have 20 bits for depth, right? So hopefully that is enough. We can play around with that. So we've got to pack it. We've got to, like, so that means if you have 20 bits for depth, that's 1,000,000. So if you have a far clip plane of 1,000, well, obviously you've got 1,000. That's the way of saying it. If you've got a far clip plane of 1,000, then you've probably got 1,000 like maybe we'll do 1024, so it's a nice number. If your far cut plane is that, you've then got 1024 sub sub steps, I think. If you did it in fixed point. I think that's right. Yeah, so that would be good then. So we need to get this depth value of this sphere. So how do I get a depth value? The thing is, I'm doing this sort of count screen bounds thing, and it's not going to get me a depth, is it? Whereas the other function was doing it with the clusters up here. Outer screen bounds of ABB, and it gives you back a closest depth. That's what I need. So why don't we try and get this to work instead of the other function? I think this would be good. So rather than using this old calc sphere outer screen bounds thing, instead we're going to be using this lovely function which does the outer screen bounds of a axis line bounding box 3D. We need so we've got the view from local. We need a local space position and a half dimensions. So we do have that here. Position in local space in local space, and then right, okay. Yeah, that was because we're going to do one axis right now. Like, we don't support ellipses yet, but we will do. So where's the radius then? Dim. Sphere dim. I think that's right. Oh, dim divided by 2, right, okay, sorry. Right, so we should be able to delete a lot of this stuff now. Right, don't need that no clip stuff anymore. Okay. Then we do the occlusion test. Yeah, let's figure out where we can get that occlusion code from. It's up here, isn't it? So there's a function called isOccluded. We got the occlusion texture, which we've seen, right? It's this thing we're viewing here. This is the occlusion texture. So it's just a depth value, and it samples a single all 4 pixels now, and it will pick the maximum out of those 4 pixels and get depth and see if the sphere at the closest depth is in front of it, and if it is, it can render. If not, it's occluded, and we can skip rendering this sphere. So at the bottom left and top right and closest depth, we pass that in there, and it'll do that occlusion culling occlusion test. Now we get our sphere, got a color, it's hard coded. We insert our sphere. Now the thing is that makes, like, this is not good code. Like, we got 4x4x4, right, which is 64 threads. Possibly at the same time, going to this memory location and saying, hey, atomically add. Right, it's not very good. So what we should really do is get the number of spheres. Like, a better way to do it is just go spheres to add. equals wave active sum of 1. So this is going to make it so that any thread that is active is going to add 1. And so if it's not active, it won't add 1, because things could have been returned early here or here, right? If there's no sphere, or if the sphere has been occluded, then we need to get the thread, which is the first lane. Wave is first lane. So if the wave is first lane, it is going to spheres start index, call this thing this. It is going to do the atomic add once. And so that will reduce the amount of slowdown that we'll get from using an atomic. But the thing is, this is only do 32 threads at a time, because we're doing wave 32 mode. Maybe we can make it so that the two compute units within the thread group wait for each other and do it all together. I don't know about that. To do, see if we should do this across the thread group and use RDS. Something to think about. So yeah, now you've got to read this back. So the way I'm going to do that is I'm going to set the C32 max, and then I'm going to say this is equal to wave active min U32 of itself. So of all the threads that have this, which is the minimum one, and that one will surely be this, basically, right? So now we want to do a wave prefix sum. And a prefix sum is just like a sum, but instead each thread gets the, so it's as if wait a minute, the base index in there. Okay, so a prefix sum will basically, if you have 5 active, for every active thread, it's going to add the number that we say it to add for that thread, and the return value is all of the is as if you're adding all of the threads which come before you and including yourself. So the ones after are not appended. So this is just a way of basically saying, yeah, get my active thread index number. So then that is plus there, and then we've got our thing here. So we insert our sphere into that array there. So spheres only get inserted once into this array, but multiple times into this tile binned array. So now we've got depth value. This is really great. We just got to figure out how to pack this guy. So we've got to pack it into fixed point. Yeah, I think so. I think that's the way I want to go. The way we worked out, which is good. Alright, it's this bounds thing. Wait, I did delete some code. No, I didn't. So tile space now. Okay, so we've converted the screen bounds of bottom left and top right into tiles now. They're tiles that go across the screen like this, right? And we're going over all of the tiles that the sphere will go over, and we're adding into an array. There's two arrays we're adding into. We've got this sort keys array, and we've got the sphere indices. So this same sphere index that we've got here just gets repeated in this array, right? And we need to figure out the sort key. So we'll get that. We'll make this boy in a second. And so the beauty of this system is we just sort these two arrays, right, based on the sort keys from the sort keys array. Then everything is tile binned with variable sized arrays in each of the tiles, right? And they will be sorted front to back from the script, from the view, right, in depth as well. That'd be really nice. So this insert index, we've got to sort that one out. So basically, we can figure out, like, again, terrible, never do this. We've got multiple threads all hitting this same global thing, and we're only adding one. If we can avoid this, it'll be a great speed improvement. So what we need to do is have probably our tile binned start index, and this is, we also need to get the number of tile binned entries count that we're going to add, or entries to add, or whatever, right? So this is just simply basically doing a multiply between the difference of these things. So we've got the top, so we basically take the right hand side, right, take away the tile bottom, the left hand side, right, multiply that, so it's the width of tiles we're going to span by the height of tiles that we're going to span. And then that will get us the number of tiles. So basically, right, this is a 3 by 2, so we get 6 tiles here. So we're going to add 6 to here. And again, we should probably see if we can share this across the thread group and use LDS, because it's probably better to communicate via LDS than do this once, I imagine. But there's only 2 threads, because this is 64, but we run in wave 32, so there's that. So yeah, to do, because it requires a little bit more work, and I'm not sure how much a big one it would be. It'd be interesting to see the difference. So yeah, this will make the shader far less noisy in terms of the performance, because we'll be writing less to this atomic memory address. So, or atomic memory location, variable at that memory location. So the sort key, we've got to pack the tile index in the high bits. So we need to shift that into the right place. So we've got the tile index here flattened out. So it'd be tile index, shift left. I think it was 12 bits big. So it's 32, take 12. 20, exactly, that's right. So we've got 20 bits to use for depth. And those go in the low bits, because we're going to sort by tile first, then by depth. So then here's our fixed point, depth fixed point. So the fixed point of the depth will probably be 10, 10. I don't know if that's a good idea. But it's fixed point depth, we'll figure it out. So we've got our closest depth value here that we've calculated from a screen bounding box. So You got your screen bounding box. It'll be this one here on the near side of the 3D axis line bounding box. It'll be this one here because that's closest to the camera. Yeah. I think we've got maybe some edge cases, but basically. And we get the depth from the center to that thing. So given that valley, you've got Jeff. Thank you so much for the raid, sir. Appreciate it. How you been? Welcome, raiders. Appreciate the raid, sir. So if we did let's just say 1010 explicitly. I don't know how much of a good idea it is, but yeah, maybe we can tweak these. Now we'll do it this way. So let's just say the far plane is at 1,000. Definitely tweakable. I'm good. This is crazy that you're doing your own C compiler. Yeah, man. It's great. It's been really useful and really handy. Yeah, I can share CPU code between CPU and GPU, so it's been really nice. And not write in some other language, which is yeah. So it's cool. So we need to really have like a far plane clipping thing as well and stuff like that. I've not done any frustum culling. Yeah, let's just say, so we got our depth valley, closest depth. So what you need to do is you need to store the integer part in the high bits, the high 10 bits. So you want to take you want to cast it to it's also going to be positive as well. So you want to clamp it between 0 and 1024, probably 1023. Then, so I guess this is your well, no, because if it's outside of that range, you just don't do this. So I guess we should probably do some proper frustum culling as well. Is occluded. You know, maybe it's part of this system. No, because it's not really occlusion though, is it? You know what? Let's not bother with it. Let's just do the thing. So it's closest depth divided by 24, probably. So that'll get you that way it could just be some shifts, I think. Or a shift rather. What do we want to? So if you have a value of 1024, you're gonna get a value of 1, isn't it? Oh shit. I just realized. Maybe we do on the clamp. Yeah, so you take this depth and then stick the integer part of that, put that in the high bits. And then the fractional part, so be fract fractional part of depth. So that's the bit that's like not the, that's after the decimal place. This one, you probably multiply it by 1024 and then turn that into an integer. I think that's right. We can have a bit of a play with the values, because I think there could be an off by 1. But I have done the fixed point thing before. Let me just see that, because past me's did do this. Right, here we go. So this fixed point was 10, 6. So 10 bits, integer bits, 6 fractional bits. So we just want packing. Yeah, I don't know why I just didn't grab this code before. Yeah, I could probably make a generalized thing, a macro for it, really. You could just be like pack fixed point. And you probably get like your number of, you probably just want the number of fractional bits. So fraction bits goes there. Then this would be one shift left. That, so it's one shift left 6. 64 exactly. So it'd be floating point casted, one shift left, fraction bits. And then it ends the final. So that's 6 bits, isn't it? But I guess you could just say, no. Take away one of that. Right, that's it. So that'd be our fixed point pack, a generalized version, which would be pretty cool. I guess we don't need the unpack one, so we'll just leave it. So future me will do that if future me needs it. So here is so cool. I got this depth value, and I got this depth value, and it's got 10 fractional bits. Pack that for me, please, into fixed point, and voila. Cool. So I've got this depth at fixed point. I use a fixed point now, and then I can just go in there like that. So our insert index no longer exists, so we have to fix that. So you've got the star index, we need that prefix something, I think. Wait, we didn't share these across the damn waves, or the threads in the wave. Shoot. We need to do something like this again. Bin start index. So it's the first lane. It is going to, yes, yeah, so all threads within the wave set it this to U32. The first lane within within the wave that's active is going to do the atomic add to this place here based on this. I've got to be careful. Entries to add for this thread. And then this will be spheres to add in total, which would be a wave active sum. So across all the waves, what are we adding? Then we need to, cool. So this will be happen once, which would be super nice. Then we read the min value across all the threads within the wave, right? And obviously this would be less than U32, so we'll only pull that one out. So it's the start index. Now we need to get the actual index. We're going to add probably the prefix sum of this. The prefix sum of to add for this thread. So all of the threads that come before this thread and the thread itself and the current thread itself will be added together. So you would basically get an offset to where yours will end up starting. So then this can be added to, well, you can keep incrementing it by 1, I guess. Just gotta figure it out. So you got these two parallel arrays. You're going to insert. I forgot I need to cap this value out. Uh, 20 bits, right? So that's 1 byte, 2 byte, 3 byte, or just off 3 byte. It's 5 nibbles, isn't it? Yeah, it's 5. There you go. Let's make that a bit obvious. So 1 byte, 2 byte, 3 byte, 4 byte, 5 byte. There you go. And that there. Very nice. So this needs to be incremented by 1 every iteration around here. So we should maybe call this the tile bin next index, if you will. Entry and then we shall simply increment this boy by 1. So it goes around there and then just keeps bidding the same sphere index but with a slightly different sort key, where we just pack so it might be a bit dumb doing this every time, right? So the best thing to do is just do that there instead, right? Then yes, you put the tile. All right. Very nice. So that is the new tile. Well, this is the new shader, which it doesn't really do the tile binning, but it prepares the spheres. So that's really nice. So we've got occlusion culling now, right? So that's going to be a speed improvement. So individual spheres already had a screen bounding box being produced. Now they're just going to do an extra 4 samples per sphere to check to see if it is occluded or not. And then what else? Yeah, that is a performance thing we could improve. We need to change it to a gather red instead of doing 4 samples. Yeah, I need to do that. Maybe it's negligible. And then we fill this array here. Excellent. So, why don't we plug this guy in and make sure all the inputs because we're going to be using dispatch indirect. And then we're going to sort the array. And then we've just got to work out where the tile indices start. So we're going to need to write a new shader for that as well. Sorry, where the spheres start within the tile, because it's just going to be a sorted array. So clusters, like prepare. Right, here we go. So essentially we want something like this, but it's nowhere near as complicated. Well, we're not doing many of them, just do one of them. So it goes over all of the clusters to render, gets all the spheres in there and tries to prepare those boys. So let's get these here just so we figure out. So no ring buffer, no tiles anymore. Right. But we've got these two new arrays which we haven't actually made yet. So I guess we can go and make those quick. What are they again? Those three arrays. Volume spheres to render. And tile bin sort keys. Okay. Right, here's some of these boys here. Volume spheres to render buffer ID. That's what it's going to get renamed to. Volume spheres to render buffer. Now we need the sort keys, buffer ID. Volume spheres tile bin sort keys. Buffer. So yeah, that's an interesting one. Tile capacity. Yeah, how many are we gonna... I might use the sphere's capacity on there as well. Got to be careful of overflow. But yeah, this is just going to be 32. So size of B32 there. So that's for the sort keys, and you got the actual indices as well. I think I called them indices? Yeah. Okay, good. Right, so we need to get these in the data structure. Plop them in there. So we've got those there, and we can now access them when we can make our command buffer that gets recorded. So we can do all the sync code and all that, pass them into the push constants. Cool, so we're going to find that spheres, prepare spheres now. Right. So these are the three boys. So this one, so the tile binning ones and the spheres to render array, which ends up needing to use the new buffers we've just created. I did it the wrong way around. No. There we go. And this is the spheres to render buffer. Cool. So they're all added in there. We've got the occlusion texture. Nice. We just got to do the synchronization code. So here's the sync code. The ring buffer doesn't need to exist anymore because it's not per LOD like this one was doing. Where it goes, runs dispatches once per LOD for clusters. We've already LOD selected, so we've got that in a clusters to render buffer, and this one is read only this time, right? The next one is read-only occlusion. Read write one of these boys. Read write one of them. So rewrite the two tile bind arrays, which are basically parallel arrays. And then there is this spheres to render, which is read write. So prepare spheres. Nice. So we're launching prepare spheres in direct, right? So we've got to figure out how do we do that. That's another thing I changed off stream as well when I've changed the indirect. This used to take in a buffer. You say what buffer does it come from, but since we only have one indirect buffer that the GPU system knows about, we just provide an offset into that buffer now. So we just have one global with all the indirect args in. So it's globally accessible to any shader that wants it. You just have to put the correct synchronization code in. So yeah, this is much nicer now. So we just provide an offset into here. So the only downside to this approach is that you can't have indirect args with instanced data, if you will. Like it's got to be a globally accessible thing. So I don't think that there'll ever be a problem. But wait and find out. If not, I can always have multiple buffers, I think. But I don't think it'll be a problem. So right. So this has got to be called like volume prepare spheres dispatch args. Oh yeah. So how do we fill this boy in? How do we fill it in? Sweet. So I want to comment these guys out. We can't, I don't think we can run this. I think what we're going to do is we're going to write the perfect code and then just hope it works. Yeah, because I don't think I want to. I might, actually no, I can disable the ray tracer and then maybe we can try and get it to run at least and just see it doing stuff. If I disable the ray tracer, then should be fine. It should be able to. We'll be able to see. Yeah, we'll be able to see the debug drawing still. All right. So we've got to populate these. How do we do it? So we used to do it in this tile bin allocate, which ran before this guy. But we don't have that anymore. So in this one is ran. But you don't, how do you notice at the end? I think you might, you know, we're gonna need another shader just to sort of populate the arguments. It's just the way it ends up going. So we need a setup. So you just do these a bunch of ones. Call it setup, right? We've had this before, these setup ones where I've passed in a specific they just have an LOD. Oh no, I don't need an LOD. So no constants, please. Yeah, I don't want any. So all I need to do is upload the global buffer. Sorry, upload the global indirect and read from the global buffer. Something like this. Pair spheres dispatch args. So this would be indirect args. This is a new thing I added as well off stream. So it's a bit like the GFX global, the way that one worked. So it's a globally accessible one. So we want to say equals, there's got to be ones here. And across the X, this is the number of groups we've got to launch. Thankfully, very simple. This is a 4x4x4, so every sphere gets a thread. So we need, obviously, our groups is the number of clusters we need to render. Where do we have that number? So when we add it to the array, we increment this clusters to render. So it's just this guy here. There's only for atomics because there is pipeline barriers written by the CPU which will do the cache flushing. So it's simply just, hey, read that, put it into there, and voila. That will then mean these dispatch args are set properly. We just got to dispatch the shader and put the sync code in. Is all, no biggie. No biggie. So it's something like this. So it's no push constants, no bundle constants, right? Just use that one. Then we need to have read write. Well, technically it's just read only on the global buffer, then read write on the indirect args buffer, because that's where the indirect args are going into, right? And then reading from there. Cool. So that should work. That should work. Then after that, we need to do the sorting code. And then we need to write a... Oh, what is that? Is it just called sphere? Boy. Oh. So, in prepare clusters to render, we're not doing this tile binning thing anymore. It's lovely. So it's all goes. So that should be quicker as well. I've not really got metrics on that shader. Plus, it's not too good because we're only doing one volume instance anyway. So it's just not, yeah. We've got two numbers, right? The global frame time, or the whole frame time, and also then the ray tracer itself. Got numbers for that. It's 2 milliseconds on the ray tracer and 5 milliseconds on the whole frame. We'll just see how much of a better performance it gets there. What is this? Half dim. I need that. Do you know? Play. Yeah. Cool. Position in view space. Yes. Oh. Yeah, I want some in view space. That's not good. I guess I could grab those from in here and just... It's annoying though. I could have them passed out and just not use them in the other shaders that don't need them. But yeah, I need the... Crap. I'll just recalculate it. The compiler will just optimize it anyway, because it all gets inlined. So sphere, position in view space. What is that? Why is that there? Right. Then I need to produce this radius in view space as well. You know what? We'll I've got to undo and find it now. I could have equally just looked in Git, but That will require learning. Somewhere around here. Actually, let's just redo it all. It is in the shader just below us that we've commented out. There it is. Right, that compiled, that was good. So the shader's now compiling, but yeah. The CPU side code is now compiling. Okay. So, right. The stream could die because AMD drivers suck and they like to crash real hard and bring the desktop down if you index out of bounds. So yeah, if that happens, then I'll be back in a minute, but hopefully it doesn't. Excellent. So we're getting some uninitialized issues with the depth buffer or the occlusion buffer, maybe both, which is okay. Yeah, yes, uninitialized depth buffer, which is then being copied into the occlusion buffer. This is fine. So this is wasting the sort of dust, but at least it's running. That's the main thing. So we've got our prepare spheres to render. Right, apparently it's dirt cheap. I don't know how many it's actually doing. We can see how many it's doing by simply just by simply printing out something into the terminal, right? So where is it? Or where's something that's so do you want to do like this to add maybe, or maybe even go far down as like this one, right? And maybe just do it here so it gets printed once. So we're going to print out that value. And if this value has something set, then definitely stuff goes in the array. And it should be fine. If not, we should investigate. Right, I'm not seeing anything. Let's disable the profiling because we should be able to see stuff that prints out in the terminal easier. There we go, without it on. So that's annoying. So the next thing to try out would be, hey, do we make it here? Right, so we'll just print out like this value or something. Already fast, just want to know when we reach here or something like that. So the answer is no. Oh, we didn't dispatch this thing, did we? Like an absolute wally. Sorry, ignore me for a minute. What did we do? So yeah, we ended up calling prepare clusters rather than prepare spheres. The setup function for it. So we just didn't call the right shader, unfortunately. So that's probably the reason why we're not seeing anything happen. So let's just very far away. All right. Yeah, sweet. Good. So we're seeing stuff that's being binned there, and the location thing is going crazy because that happens right at the entry point of the shader. But this one is happening right? Which means stuff is getting binned, right? So now let's look at that in the using the performance stuff or the profiling stuff. You just see what we get. So profiling wise, that is still kind of cheap as well, I guess. Like we saw how many spheres that there's kind of like probably about 1.6 million in that volume instance, which we can't really see anymore. Let's go on my Discord. Right, I dropped a screenshot. Yeah. So this is like 1.6 million spheres. So we then occlusion cull all the ones in the middle and at the back, right? So it's got quite good occlusion culling. So I don't know how many it's actually doing. But yeah, that's how much it's costing us to do that. We'll also wait and see how much this... Yeah. When we increase the number of instances, we'll see how bad this gets. But that's kind of skeptical about that value. Maybe we need to improve the performance still in that. Well, yeah, we definitely need to improve the performance, but yeah, maybe it needs to be... I guess it could be the sampling here, perhaps. We're doing those texture samples. Maybe it might not be good to occlusion cull. Maybe we'll remove the occlusion culling. Maybe the price of testing a single sphere is more expensive than just adding it to the array and sorting the array. That's something to think about. Oh, for crying out loud. There we go. So we try that. Instead now, this is, oh, even more. Oh my days. This is even worse. So apparently, even for this shader alone, it's cheaper to do the sampling and occlusion cull it, because this code doesn't run. Okay, it's good to know. Right. Sweet. So now the next shader we need to run is a sort. So we'll keep the profiling on. So prepare spheres. So after prepare spheres, we want to do a lovely graphics sort with indirect with payload. So this is going to take those two lovely buffers we've filled in, which is one, the sort keys, and then which is the indices buffer. So this is the sphere indices. So they both are parallel arrays. They get the sort keys is the one that has all the keys to sort, and this one is the payload. So it's just additional data that gets sorted alongside it. They're both 32-bit integer arrays. Now we need to tell it, hey, your is that only into the global buffer again? Oh, it's into the global buffer, isn't it? Yes, the offset into the global buffer. Yes, oh no, it could be any buffer, okay. So now we're saying, hey, where is the number of the number of things to sort, where is that stored? So we say it's in the global buffer. Then we tell it, hey, it's the offset of this is at, just got to get the globals buffer. Tile binned entries count, right? Plop that in there, and that's where it is. Awesome. So that's nice. There is some overflowing problems though. Yeah. Yeah. That should be okay, perhaps. Hmm. You gotta think about overflowing these. Think about that in a bit, I guess. So that will then sort the arrays. So all of the tiles, sorry, all of the spheres will be now binned into tiles. So all of the spheres that belong to a certain tile are now next to each other in memory. And they're sorted as well by depth from front to back. So let's give that a run. Hopefully this works. Alright, we're still here. So now we've got this. All of these shaders get launched to do the parallel radix sort. Why is that 1 point? Did I don't know. Look at that later, I guess. But yeah, so now we're doing this radix sort. You know what? I need to add ways to group these together and just get a total time because this is just, it's just not really readable. But yeah, so okay. Um, yeah, now they're sorted front to back, and then what we can do is we've now got to run a shader, which is going to go over that array and essentially do a wait, what array is it got to be? So we can know, like the next problem we have now is what these parallel arrays, and say they have little sub arrays in there. So and there's one tile, little sub array here, another, I don't know. This one's a bit bigger, and this one's smaller. So these are some tiles and their spheres within that array. Now, what we need to do is we need to somehow know where these are, where the tiles start. We don't know that because we've just sorted them and we don't know where they start. Even more code, will he ever stop? I know it. Hey, let me one. Yeah, yeah, it's executed CPU. All this Vulkan code is here, but our shaders, anything in the shaders file is all GPU. All of this is GPU. But yeah, I don't write much Vulkan per se. I barely touch that code now. Yeah, I used to do OpenGL. It's been a while since I've done it though. So how are we going to solve this problem? Well, we know how many are in these arrays, in these tiles. How many spheres are in each tile. We just need to effectively do a prefix sum, like we've been doing in the shaders, but on a whole array. So we need another array. Just need more arrays. It's always the answer. More arrays and more compute shaders. So you need another array, and this one will have all of the how many spheres. That's the way of saying it. How many spheres are in each tile? And then we need to do a prefix sum on that, which will turn that into how many, or where's the start index? So this might have 4, 5, 7, and I don't know. Let's just say 2. So when we do a prefix sum, it will turn that into 0. That's the start index. But yeah, it's kind of a prefix sum, but not, I guess. It's an exclusive prefix sum. This will be this will be 9. Oh wait, this will be 4, 9, 9 plus 7 is 16. Right, so there'll be start indices instead. And this is the shader we need to write to get that to work. And then when we have that, we have our arrays of spheres per tile. And then we can use that information to then do our sphere ray trace. Plug it into our sphere ray tracer like we had before. A bit concerned with performance though. Actually, there's a long frame. Maybe it's because OBS is running. What did I change? Because that said 2 milliseconds before. I mean, can you draw parallels and differences between Vulkan and OpenGL? Can you say like the 3 major differences between them? The question is born from my worry of Vulkan being so goddamn complicated that it makes me feel like it wasn't meant to be written by one coder. As if it's designed to be written by rendering engine coders as a team or something. Yeah. Like rendering in general is very complicated. If you're gonna do like a really good job rendering, it is a very deep subject. So it alone is complicated. Vulkan just makes that even harder, I guess. There's a lot to learn. What's the 3 major things? It's different. So what's nice about it is you get like a newer APIs and it's kind of, you know, which is kind of nice. But the thing is that Vulkan tries to work on a lot of devices. So the way it's designed in some cases is quite bad. Like the memory management is not as simple as allocating from the system. You've got different types of heaps that you get, and these different types of heaps vary depending on the hardware, and it's annoying. Yeah, 3 major things, differences. Yeah, there's the whole everything in Vulkan is basically explicit memory allocation, and if the driver wants to use some memory, it is gonna ask you for it. You also have to create and delete buffers yourself, and the driver's not gonna help you if you delete it and the frame on the GPU is still using it. So on the CPU you could say um, you could basically freeze some memory, and if the GPU is still using it, it's a bad idea. You don't want to free memory that the GPU is still actually using. Um, what else? Um, it's also got like synchronization code and render passes as well, um, which is lots of very manual process. You can kind of automate it with like a frame graph, but that's kind of questionable as well. Everything just becomes more complicated. Unfortunately, it's not a easy API. No worries. Is the documentation good? Pretty good. Pretty good documentation. Wait a minute. Sorry, documentation exists. That's what I mean by good documentation. Is the documentation readable to a human being who reads English? The answer is no. It very much refers to itself a lot of the time, and you have to understand what those words mean. And it's very difficult to understand or track down uh, meanings of the words they use in the language of the documentation. Idiomatic. I'm not sure what that means, but yeah. Just I don't know, but yeah, it's 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 not easy to just go to any example really. Um, but I think even pipeline barrier is a good one. Pipeline barrier. This one will like fry your brain when you're trying to understand this. When you first learn it, it takes all these parameters, and you're like, and then you're reading what it does. So it operates. No. It submits when pipeline barriers submit to the queue. It defines memory dependency between commands that are submitted to the same queue before it and submitted to the queue after it. If pipeline barrier was recorded outside of render pass instance, so it's very explicit in what it says. It says a lot of things, and yeah, we submit outside of render pass instance. Yeah, it's just very wordy, and it's got a lot of terminology. I guess I've got links to things which you can read up on, but even so, yeah, it's just complicated. But yeah, I recommend just sticking to OpenGL and doing that. Sorry, third line. Hmm. It gives all commands that occur later in submission order. Yeah. So you put your pipeline barrier. Yeah, it's basically just a. So you got your barrier, got your dispatch, another dispatch. All the barrier is doing is basically saying, hey, do not run this dispatch at the same time as this dispatch because I am here. And you're basically saying like, oh, this guy writes to this texture and this guy reads from that texture. So that's what the other parameters are for. But yeah, it's very overcomplicated when you when you dig into some of the things. But yeah. Vulkan. It's alright. It's alright. Right, I want to take a quick break and I'll get another Dr. Pepper. They're good. And then I'm gonna... Oh, else something else. Sorry if I ignored you there. Um, yeah, it compiles on Windows. Yeah. Here's a Windows tile box. Yeah, it runs on Windows. I got it fixed again because it broke. But yeah. Hey, Ross compiler. Single socket library doesn't overcomplicate things. Yes. Yes. You mean like an abstraction? I think it's called ZNet or ZNet. I keep forgetting it. For crying out loud. Single header. Is it ZNet or ZNet? One of them's high level, the other one's low level. This looks higher level to me. This ain't it. Damn it. Single header libraries. Sean Barrett has got a bunch of ones he recommends. Oh, Z underscore net. So this one is pretty legit. I used this when I did some networking stuff, played around with it. It just basically abstracts over a TCP socket and a UDP socket and other networking bits. It's pretty good. I think it didn't. I think it returns errors as. I think I changed it so it returns an enum. When I grabbed it in my used it in my code. But yeah, it's really good. Just abstracts over the socket APIs of the operating system, and that's it. Is more immediate. I'm not sure what you mean by that. More immediate. But yeah, it's explicit. So if you tell it, I want to do this, it will do it when you say. Like, it doesn't have a queue internally, or maybe it does. But yeah, things are less, like in OpenGL, there's no clear way of like to know when it's actually submitted to the GPU. In Vulkan, you do a queue submit, and it submits onto a queue. Your command buffer onto a queue. You're right. Okay, that's cool. No worries. No, these are not new headphones. Right, I'm gonna get a Dr. Pepper because I need to keep my energy levels up because I'm still recovering from going out last night. Anyways, I'll be right back. Alright, welcome back. Got a nice Dr. Pepper Zero. So, yeah. Oh, very good. So something I just remembered is that we didn't change the way we was doing our the number of tiles on the screen for these. So we need to get the tile dimensions. To go to the globals, tile dim, tile size. Right. All right. This is going to be great. This is going to be great. So, tile dim is probably like the way we want to calculate it is you need 60. Yeah. Let's do 32, I guess. So on a 1080p screen, 1920 divided by 32, you get 60 tiles. That's kind of what I want to do. Have slightly bigger tiles. So we have less tiles to deal with. So because we've in our sort keys we've only got 10 bits. Sorry, 12 bits. 12 bits, isn't it? In the sort key. 12 bits for the tile index. So I think it's 12 bits to be like 8. It is 8. It's 4096. So, I guess that's 64 squared, right? Yeah. So 64 squared is the most we do. So it's essentially we want to get the. How are we gonna work that out? Um. So effectively, the tile dim even needs to be like 32, or if we go above 1080p, we'll just make it whatever. Yeah, make it based on screen resolution. Right? Yeah, it'll be fine. I'm not sure if this cell size needs to exist anymore. 8. Um. Yeah, maybe it does. Okay, so now we should have less tiles. Oh yeah. Hope that's okay. So the next thing to do is we need to write a function. It's like a wave prefix sum, but across a whole array. But it's not. Getting my terminology right. Um. Ah, scan, that's it. So maybe we call it an inclusive scan. Or an exclusive scan. Mm. Because prefix sum is an inclusive scan. So if I go into the compiler, HCC spivy gen. Yeah. So it would be like, so I think it's an include. Oh, no, it is exclusive. Right. Did we get that right then? Oh yeah, excellent, that's right. An exclusive scan. Cool. Right, so that means I can use that terminology then. I can just say prefix. Great. So new shader I want to make, and I guess this could be used in some other cases. Effectively, it's a buffer prefix sum. And the idea is, and I need to work out what's best. So buffer prefix sum BC. So the idea is you basically got an array of elements and it's going to sum all of the elements in a prefix sum fashion in place. Oh, hey Ted, how's it going? That was a cat. Oh, okay. Nice. Oh, it is. Hmm. Going well. How's your weekend been? Yeah, it's been alright. Just went out with my friends last night and had some drinks. Thankfully, I'm actually okay today. In the past, it's not been good sometimes, but today's been alright. Um, yeah. So other than that, just been doing the weekend chores, and yeah. But I think this morning, like, yeah, this is my current thing where I've got this occlusion buffer and I'm rendering this sphere filled with spheres. But I got all the code working on Windows again because that kind of broke. The AMD driver is different on Windows than it is on Linux, and it requires a proper synchronization to work. And sometimes I just mistype stuff, and things just break. So I'm happy about that. That working as well. But yeah, it's going alright. Thank you. Got to think of a good way of how we can do this. So we can leverage wave active prefix sum, right? We can leverage this so that can prefix sum 32 at a time. But you got to do it across a whole array. So it gets pretty crazy. So the way we can think about it is you've got right. Um, hmm. So if your array was literally just 32 elements, you could just prefix sum that array and you're done. But it's not that simple. So let's turn the problem into, imagine if you had arrays of 32 entry arrays. Okay. So you'll prefix sum all the elements in here. And then this one will prefix, okay, they'll all prefix sum their own elements. Then this one has to also have prefix summed the final element of this array that came before it, right? The final element in there. And then this one would have to prefix sum the final element within here, right? And this one will have to prefix sum the final element within here. So I guess there's two ways you could do this. One, you could have a dependency and wait for the previous one to finish, right? In a sense. Or you can just add it on later. Basically. So So the adding it on later might be okay. Depends. So if this one, so maybe the algorithm could be you sort of like do the prefix sums on these guys, and then their final thread result gets stored in another array or whatever, right? Just need more arrays. That works. Yeah, so their final result gets stored in here. And then, so you've prefix summed, every element has been prefix summed, but they've only been prefix summed within each other, not including the ones before them. These are 32 entries each. They've all been prefix summed in their own little cell, but not with the cells before them. So to do the cells before them, you've got the max values here. You prefix sum this, and then you prefix sum this with every one of these guys, and then you take that result and add it to all of the individual elements within the cells, if you get what I mean. So this one would be adding 0 to its guys. This one, say if this with 32 values, the maximum value was like 10. This would be adding 10 to all of these elements within this cell. And excuse me, say if this one had a maximum value of like, I don't know, 8. It would add 10 plus 8 together, and so it'd be adding 18 to all of the cells, all of the entries in this cell here. Cheers, Meatball One. That was a quick hop to the shop. Seems like you've actually got a corner shop that's like next to you. So you basically fix the problem by adding more, doing more prefix sums in addition. Right, so that is probably the algorithm to do it. But the issue is, how do you do this? Like, what's the size of our thread group? Can we use LDS memory as well to sort of speed it up? Because you don't want to be writing this out to main memory when it could actually just live in LDS memory. And also, how many dispatches will you actually have to do as well? Because you probably can't do it all in one. You can't do it all in one dispatch because that'll probably only do 1,000 entries. We have 3,000, so it's going to require multiple, and it'd be good to work across any one where I want to, any other algorithm that wants to use this as well. It's like a sort function, right? It's a utility. So yeah. Like a 3-minute walk or something. Small store, cool. Nice. Hey Blackbird. Thank you, you too, sir. So, right. Um, so these 32 entry cells, right? This cell has 32 entries, this one has 32, 32, 32. You could probably then I think 32 times 32 is it's 1024, isn't it? Right. Seems to fit perfect. In yeah. So I think it's going to be 1024. I'm not sure what the uh see, I've got this Intel laptop. You know, this is how most horror stories start. Um and I kind of want to try and keep it running on there. I don't know how long term it will be of a good idea. I think it's a 620. Maybe it's one of these. Yeah, whatever. Something like this. I forget the compute shader. Oh yeah, they support 1024. Alright, that's fine. That's good then. So we can do 1024 on that thread group size. So that means you've got 32 wave 32s, right? That running lockstep. So each wave 32 runs in lockstep, but all of the waves don't run together. They can run out of. They're not in lockstep, right? But they can communicate with each other across LDS, right? Local device storage or whatever you want to call it. Um, I think it's called local data share, but anyway, I get lost in specifics. So we can have this in LDS, where we dispatch group. So that's just going to be probably just U32 prefix sum. So I could call it like cell. I don't know. Cell sums, I guess. Right, and you have 32 of those. I think that should be fine. So 32 times 4 is not too big. But I have a NVIDIA card, yes? No, I don't. No, I have an equivalent of a 3060 but an AMD World. It's a I don't know how true that is. I've never compared it, but apparently it gets compared to that. It's an AMD 66 yeah, 6600. Yeah, it's just the standard version. So it was a mid-tier. Yeah, I think I paid 250 quid for it. It's it's alright, I guess. It's not super powerful, but it's not slow. Yeah, it's not bad at the same time. So it's got 8 gigs of VRAM, 28 compute units, whatever that means. I think it's 28 dual compute units, which maybe gives you 56 wave 32s that run at the same time. I don't know. But yeah. Alright. Nice one, Pete. Represent. Vega 256. It's a weird card. Oh. Memory next to the die. Oh, right. So you've got like, ooh. The Vega, you got like a mobile. Is that a mobile unit? Has some ray tracing hardware support. This nice. Yeah, this one does too. Yeah, the RX 6600. Oh no, Pete. You're talking about right. Gotcha. So let's just write some dummy code quick. We've got to solve the problem where there's you need multiple groups, and how do you solve that problem? But let's just write this dummy code. First of all, I actually need to excuse them. Right. Right, so you also like read write buffer of U32. Right, so this is going to be the buffer you want to sum all over. There's probably going to be like a number of entries, but you probably want that to be indirect as well. So it's probably going to be indirectly provided, maybe. Be able to think about that. No. Yeah, we should probably say... Oh yeah, where's the... Shoot. Entries count buffer. So where does that come from? And the offset into the buffer of how you get it out. Yeah, bit of faff. But that'd be good. So whenever we want to get our entries count, I guess, it's a bit funny. You have to go entries count buffer entries count offset. I guess it's not that bad. All right. So that's something that'll be there. So going off that logic that we were describing, basically you'd get your so you probably would get like some form of index entry index, if you will, which is going to be your dispatch index.x probably. So this will be more than this, right? But yeah. And if it's greater than entries. Yeah, so local index will get you 0 to 23 inclusively. But this will be even higher than it includes like how many groups you dispatch as well. It just keeps going higher than that. So if this entry index goes out of bounds, don't do anything. Or just return here. Or make your thread inactive, right? So basically you want to load into memory from the buffer, the source buffer, at that entry index. Then you want to do a prefix sum on that. And this will then be your value that you've prefix summed, right? Prefix summed. Just call it value, I don't know. Because maybe it's not finished yet. So you've done that prefix sum. So you've done you got 32 different values here, which will do this at the same time. Prefix sum it and you get a value back, right? So these will write their top result. So you need to get your highest set, the highest one, right? See, I wonder, they've done this sort of scan add thing in the sort code, and maybe they do some. I remember reading it, it did seem like it's kind of similar to what we want to do. Yeah, sort scan prefix. I think this code is actually very similar to what we want to write, but the issue is that it's specifically written for their use case of sizes of bins and things like this. There's this thing here. How to get to fix bugs on AMD cards. Had NVIDIA 1660 before that, which was about the same performance. Oh, okay, really? Interesting. I didn't buy NVIDIA anymore simply because I didn't wish to support the company that behaves like NVIDIA. Yeah, I typically do it for similar reasons. I like AMD's open source stuff that they do, and they typically, this annoys me still. You can't go, hey, we got this AMD binary for the GPUs compiled. Let's send that to Vulkan, and there's your shader. No, we have to do SpearV, give that to the driver. I wish AMD would. They've given us access to sort of know that there's a shader assembly, there's a spec for it and everything. You can actually get this stuff back, and that, but you can't pre-compile it yourself and then just give them to it. Like Amadeus ISA. So you can look at the ISA and study it and understand it, which is really cool. And learn about all the instructions and it has and registers and LDS memory and blah 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 blah. But yeah. They're not going the full way yet. I'm waiting until they do. But I do like how they're going more open source than NVIDIA. NVIDIA wants to sort of like be like, hey, they want to invent new custom hardware that locks you into NVIDIA, like some AI chip or something, or some hardware for ray tracing or whatever, rather than sort of making a more open GPU. Proprietary. Ew. Yeah, unfortunately can't escape proprietary at the moment. Hey there, Kit. How's it going? Welcome, welcome, welcome. Do you prefix summed your value within a wave? Then you need to find the most set one. Oh yeah, I remember I was looking at this. How do they do it? Because they do this. Lane ID. Right, so I guess they make them all active and they just do that. Yeah, see, this is what I was thinking about doing, right? It's one of this. It's gonna be probably quite similar to this. This is interesting. Thread group sum. Calculate the local scan prefix. What? Ew. So it stores it in LDS memory and is able to. How big is this boy? 128. Used on what they're doing exactly. So they got this, which is 128 by. Oh shoot, by 16. By 4. Oh, it's 4 elements. Um, perform a coalesce loads into LDS. So it preloads the data into LDS memory. And then it's going to do a... Could I just use this thing? I wonder. And scatter load. I wonder if I could use this thing. Maybe not. Number of values to scan, because it's just prefix scanning. Group. I'm a bit unsure about some of the other parameters. Yes, it preloads it into LDS, the data, and then loops over 4 times. Calculate the local prefix for your current thread. So I being so your local ID is your 0 to 32 or something like that. Or 0 to 128, whatever it is. Get your value. Yes, so it's in a prefix sum. Like this way in LDS memory. And then it will, I guess, use the wave intrinsics in here. Then it takes that thread group sum. Right, then writes that into the sum. Add partial sums back for each wave. Hmm. Yeah, I wonder if this actually works large scale though. Yeah, it's interesting to look at. Hey Buffer Overflow, how's it going? Good man, glad you weren't all screwed up after some drinks. Yeah. Yes. So I made it home safely and I'm here today, so it's all good. Yeah, I drank a fair bit, but I just didn't go complete overboard like I've done before. Yes. I don't drink too often, but when I do, I drink. Yeah, so I'm not sure if this is reusable. Because I'm not entirely sure what it actually does still. Like, so let's just continue on to our thought train of what we were doing, our own custom one, because I actually will understand this anyway, but was looking at it so we could see like, oh, how did they get the last lane? They just did this take one, and their lanes are all active basically, which which is fair enough. Maybe it's okay to read outside the buffer and you get 0 back. Maybe that's what they're doing anyway. They just gotta make sure you don't store it in there, basically. I think that's the problem. So I think when they non-values scan, they just don't store it in there. But when they read it, oh yeah, they put 0 in. Okay. So they got you. The idea is basically keep it active. So you want to get your sort of source value, I guess. So source value. So it starts off as 0. If it's in bounds, get the value. Boom. So you then want to do the thing where you say if my wave thread index, if that is equal to wave threads count take 1, meaning I'm the last thread in the wave, I want to add so given my local dispatch, so I think we call them cells. So cell index or your local cell index, local index.x divided by 32. You've got 32 cells. Right. So we go back to the drawing that we did, right? These are cells. Each cell has 32 entries in. And we're trying to prefix sum the whole array, but we're going to prefix sum each cell individually with all of it. Prefix sum all of these, prefix sum all those separately, and so on. So we get the local cell index, it goes there, and you place, wait a minute, there. We place the biggest value in there, right? So place the biggest value in cell sums. So you've prefix summed so now you've placed them all in there. You then need to put a barrier down. So this be a control barrier dispatch group. So we wait until the atomic operations. Did we say atomic? Yes, we did. So we need to actually use atomics. So the atomic operations have done their thing. I don't know, because why didn't these guys? Maybe it doesn't need to be atomic because it's got a barrier down. Right. Maybe. That's why. Right, it's got the barrier down, so it waits until all other waves that don't run in lockstep, right, with each other, reach this point. So some waves will run in lockstep, like 32 threads run in lockstep, process all of this data, and then they'll get here and wait for the other guys to get there. They'll probably get paused when they have to do stuff like memory reads and have to wait and switch that for something else. But the idea is you don't know that. There's no strict ordering in GPU execution of these waves. They just run as and when they get scheduled. So to hide latency and stuff like this. So we wait for all the waves within this thread group of 1024 threads to get here. Now we need to do a prefix sum on all of these, right? So there's 32 entries in there. what do we need to prefix sum exactly? So these are the biggest value in all of these cells, which is the one at the end, has put its value into here. So if we prefix sum this whole array of 32, where each... Wait, what are we doing? Are we prefix summing this table? Yeah, so after that we need to say, right, get my... If I am the first thread... Wait, what's the way of saying it? I think you just want to do one... Probably if I'm the first cell, I guess is the way of saying it. If I'm the first cell, I am going to do a prefix sum based on my thread index. My wave thread index. So only one wave is going to do this code here, and it's going to do a prefix sum, grab one of the 32 elements, each thread of the wave, prefix sum that and put it back into the table. Then you do another barrier. And now the next thing to do is add the sums for the previous cells. Right, so now we know that this cell needs to add 0 to it, so we don't really do that one, but we might do it anyway. But this one has maybe an entry of a value of like 10. So all of these guys are going to add 10 to themselves. This one has like a 7 or whatever, right? This one had a value of 7. So we put a value of 7 in there. There was a value of 10 there. Wait, 10 in here. 7 there. So this will get a value of 0. This will get a value of 10. This will get a value of 17. So these guys will all add 17 to themselves. Excellent. So then we need to take... So you need to take the cell that comes before you, take that value, and add it, I think. I think that's the way. Alright, a very simple tokenizer in C. It is enlightening because I understand you can use const in specific positions to communicate that a pointer is a pointer, not an array, for example. Among other things, the example was just what first came to mind. Means that it's a pointer, not array, while what means the parameter is a I don't know how that makes sense. Because just all it means is you're saying that's a const array. You're saying that's a const pointer value. Right, I see now. Yeah. Yeah, I guess you could actually. Yeah, it's not really tokenizer, but related. But yeah, with the type system. Yeah, you're saying that the It's not an array, it's just a single pointed element. Yeah, that's true. So you want to load out the previous cell. Do you load out the previous cell? No, you load out your cell and add it. So whatever your local cell is. Local cell index, and then you're adding that value, that to your value. And then and then that's it. Then you store that back into the buffer. So that right there is a prefix sum across 1024 elements at most. It's pretty decent how it uses LDS memory. So you're only loading elements from the buffer and you're storing them back in when you've computed the final prefix sum. But the problem is when you need to now make it span across thousands of elements. So you've got two ways that you could do this. You could basically do a dispatch for every 1,000, which is not too bad if you only have 2 or 3 like we might. But if you're talking about potentially even larger amounts, probably doesn't scale well. So if you break it down into multiple versions, so let's just undo a lot of this. You can now imagine these boxes as one dispatch instead of 1,000 elements. And you've done your prefix sum on these thousands of elements, or 1,000 of elements. So you could do it one dispatch, and then you will take the largest value from here and provide that as input to the next dispatch. So it would basically just add that sort of like there's maybe like a global prefix, right, that came from the previous sets of buffers. So when you're setting up these thousands of elements, you just add in that global prefix to it, if you will. But again, it doesn't scale. So we're probably going to have to do another system that we've kind of done here, but instead that works in buffers, and it's a bit So you allow all of these thousands of threads to do their prefix sums independently, and then you store their biggest value, right? See this pattern's going, right, in a buffer. It's the same thing as we just did, but it's got to put it in a place which is globally accessible to every other thread group, and the only way you do that is over main memory. So we're going to probably need then, like, we probably need a second pass, which just patches it all in at the end. But maybe it could be the same shader, and I guess this is why they did two shaders in the parallel sort that we ported over, right? This is the parallel sort. They did a scan and a scan add, and then a scan. So I think this is them basically. Yeah, this is them reusing the code, because it's probably kind of similar. So I think, okay. So I think basically then what we'll end up doing then is, if we're the final cell, we're going to write, so our local cell index is equal to 1023, right, the final cell. We're then going to poke into memory. So this will then be the see, 1024 times 1024 is a million. Just gonna be careful about this. You could quickly go into a tree structure, but I want to avoid that. So this array here, you got to do a prefix sum across this smaller array now. So I'm sitting there thinking like, you know, you've basically just made a recursive, like, in order to prefix sum all of these properly, I've got to do another prefix sum on these. Another big array of elements, but it should be divided by 1,000. So you independently launch these thread groups of 1,024 elements. They do a prefix sum. They write their largest value into this sort of like buffer prefix sum chunk, I guess, or group sums. So you get your group index, so sv dispatch group index.x, and you poke in there your biggest value, which means that comes from, and if I'm the last thread, I poke in my biggest value, like so, into that array. So after you've poked it into there, yeah, I feel like this is very similar to that sort code we ported over. They do a scan add. That just does it once though, one group. And then a scatter. No, this is not similar to what we've done. I think this has got a very a fixed. They've only got like 4 or 16 elements, something like that. So they're able to. It's a different problem. They know the size of their elements, whereas ours is a big old array, which could be any size. So after you put it in this prefix sum group sums, you've then got to do a prefix sum over this table in place. But again, this could be, I feel like it's going to get recursive though, and it's really annoying. You'd have to dispatch it again. You dispatch a prefix sum again, but this time the buffer you're doing it over would be this buffer, and then you've got to have another one of these laying around probably. Yeah, and also what happens if you're not the last? Gonna see what does it look like. Oh, okay. Hey there, Gios. Yeah. So we've got an LOD system in now. We are trying to improve the ray trace performance and quality at the moment. This is probably not a good picture because it's going to be small, and I can't run the current thing. But yeah, we've effectively got like these debug rendering stuff now, which is great. This is the occlusion buffer being debug rendered. we've got UI as well, custom UI that I can just put down quickly and use. But here's the sphere, which is made up of tons of spheres. 128 cubed. That's what we're going for at the moment. So what about if you fill a whole 128 cubed volume, it's about 2 million spheres. So we're trying to see how quickly we can get those to render using this strategy. Yeah, thank you. Appreciate it. So if you're the last cell within, if you're the last cell, what does that mean? Because you can have inactive cells, right? That's another problem with this algorithm, I guess. Well, you still run it anyway, and it'll just do zeros. Yeah. Right, that still works. Good to get the last one. There's no... Yeah. You might be running some waves. Which basically do nothing. Okay. Yeah, so you'll poke into this sort of like prefix sum group sums buffer, the biggest value. Then you need to run this shader again on this as the buffer that gets prefix summed. And if that is over 1024 elements, it needs to have another one that it writes into as well. Temporarily. Wait, why am I... yeah. So the reason why you need to fill in this buffer is because you need to do a prefix sum on it and then add that to the start of all of your thread group, or all your thread groups needs to get this. Yes, each of the thread groups needs to get the prefix sum result and add that to all of their elements. So I guess we could allocate into this prefix sums buffer with probably some offset of like, hey, this is where we start. So in the constants. So you only know based on how much you dispatch, I think. You'd probably have to pull that from some global buffer. Ugh, it's difficult. Yeah. So just to get this to work, we could just call it 4 times with an offset and a sync code between it. I don't know how I'm going to possibly solve this problem. But yeah, we can make this optimized for small small arrays that you need to prefix sum. I don't know how I'm going to do anything more complicated than this for now. So I think just to get it up and running, we know our thing is going to be a maximum left 4 of them anyway. But this could work. We just need some form of like base, some offset value, if you will. Where's that even going to come from? It's probably going to be stored in so this would just be called like buffer prefix sum offset or whatever, or like a prefix sum base, something like that, I don't know. So this is going to be added. Be careful. Group base. Base sum, I guess. So where does that get added to? Is it just the final result? Or do you want to put it in? It's just summing, so I could just put it here. Plus global, plop that in there, and voila. So we're just going to make sure that we set this correctly. So what you're going to say is, if I am the last, I guess we need that if statement back again. If I'm the last cell and the last thread, I am going to put my value in there so the next dispatch can get it. And that's just the way it's going to work. So why don't we try that then? So where does this go? So we do that sort indirect with payload. So this sorts all those tiles. We now need to do something. Another one of these guys. With this prefix something. So bc.buffer. The buffer that we're going to be prefix summing is, I don't think we have it yet. So we need to make one up. So it's the start index. There'll be two arrays that we need. I guess we need two buffers then. It would kind of be good if they're next to each other in memory, but they're not. It's not gonna be. Sphere, tiles, tile bind, entries, start. Entry, start indices, buffer ID. I don't know, that name's a bit long. Tile bind, entries, start indices, buffer. And I'll probably have an entries counts buffer. So these guys get initialized here. Spheres, tile bind, entry, start indices. So this is saying how many tiles that we have. Spheres, tile cap. No. Just do this one for now. U32 that is, and then we'll do another one for the counts. Cool, so they are now populated. Oh, sorry, created, I meant. Now we just have to, so we actually have to pass them in when we prepare spheres. They probably need to be zeroed as well. So when we prepare the spheres, we need to have access to, which one of those things was it? We need to have access to probably just the number of spheres that will be in that tile. So I guess it does have to be zeroed memory. We can do that as well. So tile bind probably just an entries count, and there'll be like a start indices buffer as well. I guess we'll put both in for now. We can always change it when we need to optimize. We just need to get it to work. So whenever we counts buffer ID. Cool, so we need synchronization code there too. Don't forget the sync code, their read writes. They're gonna both have to be zeroed memory. So we need to make sure we do that mem set at the beginning. That we did in some other places. So be a mem set. We're just gonna mem set 0 on the on those two arrays. So we can atomically add the number. So we atomic add to these in the shader. So in the prepare spheres, we are going to, here where we work out the you go over all the tile, each tile, you're just going to add one sphere. To each tile. Probably not ideal. Maybe it's better off in a separate pass to count them. Because you're just going to be doing atomic adds with one across all those different tiles. We can do that for now, but it's really on that one. It's not ideal. Unless another way we find the start index is if we did like a binary search. That's the other approach we could do. Then we wouldn't have to fill these two buffers in. In this shader, we can binary search for it. That's the other approach we could do. But then you have to binary search over the whole array. For every tile. So you can launch 3,000 odd threads and binary search for the where it starts. Maybe that's the other way. Maybe that's the way to do it. Because we're going to be atomic adding for every tile the sphere goes over. That's not ideal. Yeah, maybe let's try a binary search. Right, so we've just written that prefix, so I don't think we're going to need it anymore, but we'll keep it obviously. Right, I've got to change the way we do it. So this one instead, we're just going to have a start indices buffer. The count is going to be implicit. Yeah, the count's going to actually be implicit now. I've just realized this. Right, so remove these. The count is going to be implicit. Do we need to clear it? No. So instead we'll probably need another shader now instead. And this one will just be binary search for the start. Of the array. So you search for the sort keys. So I guess it'll be called like volume, spheres, tile bind, find, starts, I guess. That would probably be what the shader's gonna be called. Spheres, tile bind, not tile bind. Tile bind, find, starts. Right. So that one instead, how's that one going to work? So you probably need to pass in the sort keys, right? You need the sort keys, and you'll need... It'll definitely need to be indirect as well. The sort keys and the start indices buffer. It's definitely a good one. Alright. So you'll need that synchronization code as well. The sort keys be read only, and then read write would be the start index. So each thread will get a tile. It's got to find the start index for, and I guess just binary search the array. I don't know how performance would be on this, to be honest, but it's probably better than the other approach. I wonder if you can use multiple threads to help the search and just spawn more. But I don't know. So I guess we'll just try this out. So you need to launch based on how many tiles that you have. Or the other way, so there's a binary search, or you could just read every entry in this array and just jot down if you're the thread to find the edge, because there'll be one entry which has in the high bits the tile index of 56, and this one in the higher bits will have a tile index of 57. So you found an edge, right, where there's a hard line. So maybe that's the other way. So that will launch more threads. They'll be short-lived. They will read 32-bit values and then simply... And they'll be in cache, probably. Oh, maybe not, because they've just been written out again. Because it's just been sorted, they've been mutated. The simplest approach is to simply just pick them all up and find the edge. So we're just going to do that because this is what gets it working. So that's what we're going to write. So let's find the other shader which we wrote, which I guess we're not going to use. Maybe it becomes useful in the future. I guess it's good to have it written there. Or written and be there. There's like a prefix. Where the crap has it gone? Here it is. Right. I'll put this in a bit of a different place. Right, where's the prepare spheres one? Oh, good. So I want this, but I want it to be called this thing here. So here's the constant, so we push up. Then I want to say, so I need the sort keys as read-only, and I need another one called the start indices as read-write. So let's write this shader now. It's pretty simple. Shoot. So let's just do 32. I want to do dispatch indirect as well. Just realized that. No biggie. Just get the correct name that we put there. Not 00, 111. So we want to pick out the value. So you get the sort key. Bear in mind, you're probably going to be able to overflow. You have as many entries as there are. Where's the bin entry? Here it is. So if dispatch index.x, if that's greater than or equal to that value there, then we're out of bounds, so we don't want to do anything. So we get the sort key. Well, you're going to read two. You're going to read two things out. So actually, you're reading two. So we might need another shader which sets this thing up. So if times 2 is greater than or equal to that, then we're done. So this is what's known as the source index, I guess, or pair start index. Pair start index. So now we pull out a pair of entries. Bearing in mind, if we're at the edge, if we're at the end of the array, that's what I meant. So if this plus, we just don't do anything actually. So it's like if this plus 1, so if I'm the last element in the array, I don't want to do anything either, I think. Yeah, so if you don't have a pair and you're the last element, then yeah, don't do anything. So now you grab your two sort keys. So sort key 0 and 1. So that'll just be BC, whatever sort keys, this thing. So this is our boy. You want to fetch pair start index plus 0. And you duplicate that line like that. Now you're simply checking the high bits for the tile index. Tile index 0 equals sort key 0 shift right 20, because we store it in the 12 top bits. Then you do the same thing for this one here. Now what you're saying is if tile index 0 is not equal to tile index 1, then what we have is a boundary. So this will now be where, so we say BC, yeah, I'm not sure how good this strategy is anymore. I'm hoping that it's good enough. Because we're going over the whole memory, but maybe it loads it into cache. So maybe it's a good idea also. I don't know anymore. Or maybe it doesn't matter so much. That's what I mean. So then we want to put 1 gets the start index of pair start index plus 1. I think that's right. So you're saying like, hey, I've got these 2 entries. They're not equal. So this one now starts. Yeah. Nice, that's good. Obviously we're missing, so we need to probably say like, oh, by the way, if we're the first thread. Oh no, we'll do a kickoff one. We'll do a set one of these which sets up. So this will be called setup, and it will set some indirect arguments so we launch correctly. So the indirect args would be something like prepare spheres, no. Right, this big old name. So this would be based on the number of entries. You want to do a sort of a divide roundup on 32. Bear in mind, I think we want to multiply this by 2. No, divide by 2, that's what I meant. Or is that another divide roundup? No, you don't want to launch it on the last. If the final one is if there's 1 entry at the end, you don't care about it, so divide down is fine. Or round down is fine. Right, so that'd be the dispatch args that we use. So here we're going to say dispatch indirect, and we're going to provide an offset of indirect args into that. Very nice. So we need to do a setup function, which we've done before. So the setup function is probably going to be quite similar to this here actually. But it calls the setup version of this. So it sets up the indirect arguments, but also it's got to set in the first tile that its start index is 0, because that's obvious. Right, I'm disappearing. Just switching on the light. BRB. Right, so hopefully this works out. So we should be quite close to, if this shader works, should be quite close to plugging it in really. So let's fire this away. Right. So the stream crashes its AMD, drivers, but hopefully it doesn't. Right, we're running. The sphere ray tracer, all my days, that's slow. That is slow. How is it? Front lab. It's running at 38 milliseconds. Like, something incredibly wrong is happening. So the value we've poked in there, I don't know what that was, but obviously it's very wrong. Or is it? Like, what is this? Printf, plop that in there. Right. Crap, that's a big valley. Ooh. So, have we really just tried to bin such a large amount of spheres in there? Hmm. Oh no, I've not cleared the memory to 0. Why? Yeah. Classic. So the classic thing is I need to clear these boys. Then the frame initialize shader, so it just runs it at the start of the frame. It's going to clear those out. Yeah, so I think we're trying to sort too many entries as well, so it's complaining. I don't know why the other thing's not rendering anymore. Right, so it's actually really quick to go over all those entries. That's good. It's actually not bad. Let's just double check. Ah, shoot. That is 0. Is it off screen? Something's up with the depth buffer again. Oh, there you go. Sweet, sweet, sweet. The valley's there. That's good. Why is there so much code? Where? Hey, Ransel. Yeah, there's code everywhere. It's how you fix problems. You just add more code, or you add more buffers, or add more compute shaders. This is the way. Hey, I got a problem. I need to fix it. You know, just add more compute shaders. This is the way. Yep, more code. Our shader code, I haven't bothered deleting a lot of stuff and I've just commented it out. There's 5,000 lines in there. It's fun. I need to clean that. Right, so we know it's working now. We've got less than 65,000 spheres, so that's good. All right. So I think we just got to plug it in now. So we've got 1,000 binned spheres. That was it. 1,500. So now we just got to plug in the renderer, the sphere ray tracer, the tiled ray tracer. So we're re-enabling this boy, but everything's kind of broken. Right. So there's a. We just need. Just need. We need this one, which has the start indices for all of the binned spheres for each of the tiles. So each tile has there's a start indices from this. We can work out the count by, getting the one after me and doing a subtraction. So it's quite simple there, and it should be in cache anyway most of the time. So it's quite an alright operation. But then we also need the indices, right? Because that is where the sphere index is going to be. right? So we'll get a range into this array. We don't need the sort keys anymore because the sort keys only contain the tile index, which we have already, and a depth value, which we don't need, or a rough depth value that we don't need. We're going to poke that in there. Rightio, so here's the plan. The spheres buffer goes away. And start indices. Oh, I need a spheres buffer actually. What am I talking about? Sphere. I think I call them like volume. I don't even know anymore what they're called. They're up here. Volume spheres to render. Of course. What a good name. Alright. Nearly there now. Hopefully we can see this working again. Not sort keys. This is good. Rightio. Gotta be careful. Yeah, they're all read only. Gonna be legit. No, spheres to render. I have a really difficult but very simple problem for you. Do you want to hear it? Sure, go ahead. What's this very simple but difficult problem? Right. Here we go. Let's get the shader working now. So, this is our ray tracing code. It's not the best. I'm going to probably delete some stuff in a bit. Because, yes, it's old code, debug code that I don't need. So what I need to, we got our tile, coordinate. What tile do we land in? We get a sphere, a number of spheres, right. So that's in our new array, which is this one. And we're going to load from it we're going to load a start index, and then we're going to load an end index, which, if this is greater than the number of tiles, which I forget this number, tiles count, we've got that, nice. So that is greater than the number of tiles. Then make graphics global. Then so it's less than that, sorry. +1, that's what I mean. So not the last, yeah. We'll grab the next one. If not, we are going to put in there the number of, where is it? The number of entries that have been binned. Global, one of those, right. So now this is the end index and the count is the end, take the base. Rightio. So that right there should be... Oh, okay, there's this thing as well. So now they're called clusters to... Oh, wait a minute. You gotta fish it out from the start indices or... Oh, the indices array. Did I get that right? Yeah. Entries, start indices. Then we get the sphere indices. Okay. So sphere index or sphere to render index. That'll go into here and then fetch out. So it's a bit of indirection, which sucks. Spheres to render. And that should be it. Alright. So this could either crash and burn, or it works. And then we can fix the anti-aliasing and make it amazing. Because they're all sorted front to back now. Hopefully. Hey, the chosen one has again. Alright, so hopefully the stream doesn't die here. Let's go. Why? But it says here that the computer... that this is computer coding in general. Okay. Dude, the menu is way too wide. Yeah, this is because I attached it to a 4K monitor. Right. And then I unplugged it and put it back to 1080p monitor, and it broke it. Sad. And I don't know how to fix it. Oh, I've not been bothered trying to fix it also. Yeah, it's pretty crazy. Your GPU crashes if you index out of bounds on an array. That sucks super hard. Yeah, it's real bad. Basically. So what I might do is... what do I want to do? So there's 3 arrays that you read from, right? So the first thing we're going to do is not... Right, I think I get the music back because I think we're not going to crash it again. But yeah, I think the idea would be disable parts of the code, check the values, and then re-enable bits as the values make sense. I think that's the approach I want to take in getting this to... Do you mean to say that my donation actually helped you get better hardware? So much. This is nicer to hear, sadly. And I'm jobless, so I need to be a bit of a freeloader. Oh no, you're jobless. What happened? Yeah, help me get better hardware. It's a very great donation. Thank you so much. Appreciate it. Yeah, because before this I was running on a laptop, wasn't it? Was that right? Yeah, I was running on a laptop, which weren't good. Um, Firefox? I don't know. It's just got an ad blocker built in Brave, so just get that one. That's all. Any reason why? Because the internet is like appalling. So filled with ads. I know you can install an ad blocker, that's effort. Um, so in the shader code, we do the tiled ray tracer. What is this saying? If there's spheres, put red out to the screen. So what we can do is we can put a return there. Did we initialize this array? This buffer? Yeah, we did. Good. Right. Do that +1. Alright, so what we're going to do is we're going to debug these guys. If you have spheres. Right, so this shouldn't crash. Right, it's putting blue out to the screen if it has sphere. Wait. I don't know anymore. Yeah, if your tile has spheres. This ain't good. So let's do an if tile index equals 0. I want to know a few things. I want to know, like, what is the range in which they are at? So the range, let's do dot dot, so it's not treated like a minus. And then we need a new line. So it's base sphere index, end sphere index, and then spheres count. So if this is equal to something other than nothing, then there's a clear problem. And I got too much of this damn performance stuff in my face. Need to get rid of that for now. Right, so the numbers we're getting are... What the crap's going on here? Right. Right, sometimes you can have too many that are rendering, fair enough, but... Is the count not even showing? Oh, it's not even gonna debug print it. Right, whoops. Because it early's out. Okay, so apparently it's got, in tile 0, it's got spheres, which is wrong. It's just plain wrong. So end sphere index is equal to something. So these are obviously set up wrong. Alright, let's figure out why this is wrong. Hmm. Yeah, well, yeah, it's open source and whatever, innit? I don't know. Yeah, it's just a web browser. Um, so what is wrong with this code? Find starts. Use the correct indirect args, yes. Okay, I think this is all fine. So something to do with this code then. So you're checking all of the entries. You're grabbing key. Two keys. You're grabbing the tile index. And you're saying, hey, when the tile index differs. Oh, but maybe. So it must be sorted, right? It must be sorted. What I would hope to see, so we should only see this so many times. So that means we should be able to do a print. And we shouldn't get polluted with too much crap in the terminal, right? So what do we need to put into here? Probably need to say, you know, we could just say found uh, this from that starts at this, I guess. So you're gonna say tile index 1, tile index 0, and then like this number here. So let's see what that's that, because these should only be one apart. And if they're more than one apart, then there's something wrong with the sorting. The sorting didn't work. Hey there, Pierre. How's it going? Good evening. How you been? Oh, I got too much stuff just spamming out into the damn terminal. Um. Hmm. Where's that print code? Oh, it's in the ray tracer, isn't it? Right, let's comment out for now. Right, here we go. Let's just get out of this lag spike of craziness. Right, we're out. Right. Huh? So this many entries have been binned. 16,000. Tile index. Oh, of course there could be no. Yeah, some tiles can have absolutely nothing in them. So yeah, being off by one is fine. I get. Sorry, not having a difference of one is required. There could actually be a gap. Right. So if you're trying to render a tile that hasn't. Crap, this is a problem with this method, isn't it? I guess you've got to do a for loop then. So you probably got to go for every from this plus one. No, not that plus one. To that. So plus 1. I think that's what was missing, is a for loop like that. So that's out of all those start indices. Sweet, good to hear, good to hear. Did you fix your, have you found any more things to solve your text problem? Yeah, this is the way. If not, I've got to find a for loop and then copy it. Being lazy. But yeah, did you find any solution for your text problem that he's having in the end? Okay, so I think this is what we were missing. So what I can, so you can have like 3,000 tiles though. So I imagine it was never getting a value or something like this, or maybe it was, and yeah. So now they should all be getting filled. 0 to 1. What about the end of the array? The start of the array is fine. But the end when you go out of bounds. Yeah, you don't care about the final tile, do So the start index at the end of the array. Where's that gonna be? How's it populated? So if you get a pair, and if the key no, the end of the array will be fine. Yeah, this is good. Right, so I think that's the fix. So if we go back to the tiled one, what we should now be able to do is untick this and just look at tile 0, and that's never going to get anything until I put something in that space. So yeah, it's very difficult to see. Oh, it is. Well, it's wrong still. Don't know where the tile is, to be fair. No, I tried the mesh method, but didn't work out very well. So I'm tabling it for now. Right. Yeah, he's not trying to do it less than 10 pixels. I don't think. I think the issue is, oh, right, I see. Hmm. Yeah, but yeah, yeah, I think the part of the problem as well is trying to rasterize the glyph once. And put it into a texture and just reuse that one as well. And not rasterize a specific one for the size of the font you're trying to render. But I guess that was working a different way because you're doing it with the the TTF to mesh. Hmm. Yeah. Text, man. Complicated. Damn it. It's also my tiles. down these tiles. So I think we're going to go back to that. So it should be filling in every one of these now, basically. So we should be able to say like, oh, this one starts at, so it'd be like index +1 starts at there. All right, here we go. Nothing. Binned nothing. It's just, it's on the screen though, I don't get it. Is it really? Ah. So here it's printing out. Oh, there's a depth buffer from the previous frame that we're occlusion culling with, isn't it? Let's not do that. That is not a good idea. Shoot, what the crap's going on? Right, okay. Right, part of the problem is we're taking the depth buffer from the previous frame, but it's uninitialized. It's not being initialized. So when we do that sort of reprojection, which we don't actually reproject yet because we're just testing it out. When we take the previous frame's depth buffer and use that as the occlusion buffer, it's got garbage data, meaning it's making stuff occlude. We'll enable that in a bit. Right. So it's printing out a ton of this stuff. So it seems like it's getting some start indices, although I don't know. That is skeptical. It's overwriting the same one at different positions. That's not good. Unless that's a for loop that I didn't. Oh, that's really bad. Crap. Okay. Let's see what these numbers give us. Right, so we get this sort of range here. And I know I don't feel like it's sorted in some of these cases, and it's probably printing out that other thing when it tried to do the sort. Where it basically says it's more than 65,000. We should probably up that number then. Just in case. Oh, where is it? Where's the number of sort entries? Here we go. So why don't we make it like, I don't know, like 1 million. It's only like a megabyte, right? Or 4 megabytes. It's in the megabytes. So let's do like 1 shift left 20. And that should hopefully be enough for what we're doing. Alright. So I don't think I don't think it was being sorted correctly. So you was getting tons of pairs that were showing up, basically. Right, so let's look at this then. So you're getting a bunch of ranges, which has just got a 1. So it obviously just sets it to a value. Where's the multiple ones? Where it spans multiple? I guess it's just filling up the whole screen, so all of the tiles were getting... Oh... It's difficult. Let's run it again. Oh, things appear to be kind of working. Just obviously look a bit weird because the depth... Yeah, so we're rendering blue where there is spheres, basically. And as you can tell, it seems to be a little bit... I'm able to draw... So obviously the previous frames where the spheres went kind of stay there, and then the y-axis can sort of go, and I don't know what's going on, but it's interesting to say the least. So we're getting a range here, 820 to that. So we look for 8, 5, 5, 3. Yeah, you never set that twice to a different value at all. That's a different frame entirely. Sweet. Okay, so I think, yeah, it's just that sort buffer needs to be big enough. That's the problem. So this is fine, but there's still an issue where it appears that not all of the gaps are still being... Not all of the gaps are being set somehow. Maybe that must be. So maybe let's go to the tiled ray tracer. This is the thing that's outputting blue. It's simply saying if we have spheres, then put blue on the screen. So yeah, as you got the y-axis, it seems to be clearing them a bit. They stay there in the buffer. Maybe the ranges do. Hmm. So we go across on the X and go up a Y. The tile on that line gets... And if you go off the screen, it goes absolutely crazy on the left hand side. Oh my days. Right, hmm. Hmm. Yeah, it's a masterpiece. It's a work of art. This is just uh Just all the glitches, just insane. I'm just perplexed. If you're getting a pair, every frame you're going over all the... Right, so put it this way. So the first tile to ever get something, to ever get this tile here, is the first tile, if you was to go across the x-axis, going and then down, is the first tile to get a sphere, I guess. So in that find starts thing, you're saying, hey, from... you're not even saying from 0. Right? The 0, 1 is not going to exist. Okay, that's the problem. So it seems like it's happening both ends. It's happening prior and actually after. So yeah, you're never going to get all the ones. So you probably need to also keep track of like, hey, what is the valid range of this buffer? And if I go outside the valid range of this buffer, default to a 0 or a max entry count or something. Right, I think we found the bug. Any tips for starting a engine and graphics programming? Graphics programming specifically, one of this last stream, you probably want to write a software rasterizer. As in a triangle rasterizer. Something like this. You can basically write out you'll learn how OpenGL, or kind of what the job is of OpenGL and Vulkan is to do, right, is to rasterize triangles to the screen. And you'll learn a lot along the way. So the first thing will be just to sort of get it rasterizing, but then taking it a step further and understanding what shaders do and that. So I said yeah, so there's someone who hangs out on my days GitHub in the chat, but also in the Discord as well. And it's I mentioned that he should do this, and then he took it to like level 10 and basically wanted to learn and understand how Vulkan worked. And he basically did a software renderer and tried to sort of do a simple version of the Vulkan API and learn about vertex shaders, pixel shaders, and writing sort of this in software, or so CPU side. It's got pipelines and pipeline state and all this stuff, and just basically implementing that behind the hood and creating these images here. So I'll drop that as reference. One thing is though, is that you probably, if you try and get a window open on via the calls to the operating system, and then trying to sort of render an image to the screen is actually quite a bit of work. A quicker thing to do would just be to make a PNG file in your application, just output a PNG file, probably use an STB image, right? That's the simplest solution. But also in this repo here, there is a way to open up a window already implemented for you. So maybe you take this code and sort of just the code that sort of opens up a window and allows you to render or take the pixel data and put it on the screen, because that is a bit involved, unfortunately. But there's resources here as well, so I highly recommend you take a look at this as a reference, but implement your own software rasterizer, because you'll be able to learn how these graphics APIs work under the hood and what they're doing for you. Hey, Nogo, how's it going? Devlogging from day one. Oh, you know, I've recorded the whole thing. There's a VOD channel. There's a VOD channel, so you can catch everything on the VOD channel, every stream. But the problem is I haven't really done any devlogs because it's a bit time consuming. Thinking when things get more graphical of doing maybe recaps. I've just got to do, unfortunately, a recap of all the stuff we've missed already, or I feel like I have to do that. So that's something I've got to try and make happen. So we're going to have an acceptable range. That's what I want to call it. Where's the globals? Right, so we're going to have a sort of valid start. Tile valid. Tile binned entries valid start valid is we're not gonna have oh, tile, yeah, valid end. All right, so basically when you do the frame initialize, we have to initialize these guys with a sensible value. So that would be valid start of E32 max and valid start of 0 or end of 0. So we can do a min-max operation, I think. Maybe a good idea. I don't know. So to do that sort of like find starts or whatever. Here is when you actually get to set those. So you probably want to do like an atomic min on the start. Take the address. And you want to min your tile. You're not putting in tile index 0. Maybe that +1 is actually getting a start index. Then the end is going to be tile 1. So that's the valid range. So we take that valid range into that tile ray tracer. What we need to do then instead is we need to say, right, if your tile index is less than the start, or if it is probably greater than or equal to greater than the end. I guess it's an inclusive range, but whatever. Then you want to be using the default value. I should probably phrase that differently. Less than the end and greater than the start, so I probably want to just move that around like that. Greater than or equal to the start. Less than or equal to the end. Right, and then do an and on that. Right, so if it's valid, we'll fetch it out of there. If not, we get the base, with the default value of the beginning. And then the end. It's kind of... Right, so the way this one is going to work is... it's not tiled. Tile index. Right, tile index +1, +1. If that's outside the range, then your default value will be that instead. Right, I think that's good. So let's debug this. The debug drawing where it's blue, where... Oh crap. What did I do? Oh. Yeah. Oh, no. Something is painfully wrong. Is it this line? No. Right. So it's the fact there's an AND operator, I'm calling it. It's the fact there's an AND operator in a ternary condition. What is it saying? What predecessor of that? Did I handwrite the phi? Maybe. Line 26? It's relative line number, so I think I've lost it. Yeah, I think Peter, the min. The atomic min is just going to compile to the same as it is in GLSL. So it's just going to be subgroup uniform min, whatever it is. Group min, group. These things. Yes, so it's like a subgroup. E min, F min, whatever, I don't know. Non-uniform. Yeah, so it just uses this, which is what GLSL uses, or HLSL. So it's gonna be the same basically as whatever the other drivers do. Yeah. Well, ternary operators, what have I done? How would that be an issue? Just quickly peep into the compiler's code. See if it's a obvious fix. It's in the abstract machine language generation. It just takes a syntax tree, turns it into a high-level assembly. Ternary operator. So the condition expression. Generate condition if they're constants and they're not. Is there any fires? Oh no, so we don't have yeah, does the basic block param which compile down into fire nodes. So we have basic block parameters, not fires. Yeah, in our assembly. Whereas SpearV has fire nodes. Right. So yeah, something's up with. So we do this. Right, it's probably something to do with the basic block. It's not getting updated. Um. Hmm. So you get the condition. Yeah, current basing block true final right. So where's the basic block? Ah, here we go. Basic block, current basic block. Where's that passed in? Here. Right, so I think it's something to do with this. Patch the converging basic block operand into the branch instructions that target it. So it's saying that probably one of these. So I wonder. So you're saying, hey, if I come from this basic block, take this value, and that's what you're doing. So when you get this, oh shoot, no, the compile error. Incoming basic block ID is not a predecessor of that, right? So effectively what this is saying, I can draw it out, it's going to be quite simple. So effectively we've got, you got the ternary operator, right? Oh, come on. Here we go. So you've got your, you got this, right? This and that, right? So you've got your first condition, right? This gets evaluated. And then if that is true, it branches over here. If it's false, it branches over there. Or actually branches all the way down outside the if statement, right? Well, it branches all the way to probably this value here or whatever. But anyway, this is true. Then you do another condition, which would be this, another one of these guys. And if that's false, you'll go all the way down here to that basic block. If not, you carry on down here. And then this will give you a value of 1. Let's give you a value of 0. And so what's happening is you have this instruction over here, and it's like, I am a value, my value is dependent, and this is where the fire node comes in. But we take them as the basic block parameters. So at the start of the basic block, we have a parameter, and we say, hey, if you come from this branch, you're 1. If I come from this branch, I'm 0. So what's happening is, it's not saying if I come from this branch. What it's actually saying is saying if I come from the branch up here, which is not direct, like this code never says go to that branch. It says no, go to this branch where I calculate this. There's no branch instruction to here, right? So that's the problem. We can fix that, it's quite easy. So to fix it, we basically just say, I think I called it like a true basic block, or final, right, okay. So after the condition expression has been evaluated, then they go, oh, right, so the final Right, okay, so condition final basic block equals the current basic block. Because this condition could have generated more basic blocks, so this would be different. Then this has got to be that, this one's got to be that. And I think that will just work. So I can't, I've got to go into HCC for a minute. And then I've got to actually, let me close this without saving. Oh, sorry, close the whole buffer. Then if I do a release build, and then if we go to the sample code, just check it runs still. And there it is, look at that. So that's still running, the sample still compile. So just take the latest binary and chuck it in there and it should be able to fix. Oh, sorry. Build. What am I looking for? This one. Alright, so if we just give that a compile now. Still the problem. No. Um. Okay. I was saying if it is a constant. No, so that is not. Oh, ooh. False is a constant. It's right here, it's a constant. Also interesting, so we chuck this in a value, just call it 0. And then it works. Oh, interesting. So we... Right. That is interesting. So... It is definitely this thing that's wrong. So there's a converging basic block. And you're adding a parameter to it, and if it comes from that final... No. Oh, there's a few places it can come from. There's a few places it can come from, isn't it? Wait. No, there's only... So this would just produce either basically 1 or 0. Hmm. Yeah, maybe that's when it compiles it to native GPU stuff, yes. That's right. Yeah. Um... That feels like it should be right. So I've made this condition. I then place a selection merge conditional branch. I either go to the true or the false branch. Maybe I've not maybe I've not tested. That's a good point. Is it because of this? Right, that works, but as soon as I put that in, it doesn't work. Okay. I've I did do a release build, right? I copied it over. Let's try that one more time because I feel like it's correct. I just never copied it right. Right. Let's try that again. Damn it, compiles it fine now. Right, so that is the correct fix. Apparently I didn't copy the binary correctly. Right, so we run this, we should see, hopefully, blue. Only where we should see blue, right? I should get out of there. So just where the spheres are, basically, in the tile bin. So the tiles that light up blue should only be the ones with spheres in them. Get out of here. Alright, let's try that. Seems like the opposite. So we're kind of getting the area in a way, right? It's where the tiles should light up blue. But along the X, they're not an opposite. Yeah, so something weird's going on here. So if it's valid, then choose that from there. That should be +1. Right, okay, we're getting close now. So, oh, come on. So we just made these valid, but they're all invalid. Like, why are they showing up all blue? Yeah, they're getting a tile count. Their base sphere index or whatever it will be, yeah, so you're basically making it span the whole thing. You should just put it as 0. Wait. No. You should make them both do... So the easiest thing to do is just say if this current one is not valid, then... Crying out loud. So if this current one is not valid, we're just going to bail. And so that needs to be inverted. So then that reduces that down to there. Now you're saying if this one is invalid, we'll just go to the end. I guess it's much easier just saying if it goes is less than the number of tiles. It's better doing it that way. Okay, let's try that one out. There we go, look at that, excellent. So now the spheres are only... So now the tiles that have spheres are only the ones that obviously where the model used to be. So oh. Think sometimes oh, there's some glitches still. Oh no. I wonder if I run it. So what happens if this one isn't valid? I think that's the issue. Yeah, so we actually probably need to go back to that. Check. No. Hmm. So I wonder... I wonder what causes the tile to get filled with at least a sphere. Because it's just it's a bit weird. It's probably to do with the... So it seems to be happening on the next the next row. You're not trusting stuff near the edge boundary, maybe. Yeah, so it's the next type of... Then on the next row, there seems to be some tiles that get it. But I thought that's covered by the valid range. Right? I thought it was covered by that. So we set those to mins. Hmm. Hmm. And then to just end of maxed. They'll always get min maxed to something. So this condition here could only be... Hmm. So it picks up... It means that it actually gets past this code as well. If it's able to light up blue, it gets past this code where this tile ends up being valid. And then... You know what? Did I put the right sync code in? It's got me thinking. What have I done on that fines buffer? I've not even synced on the global buffer. So that was a problem. That's probably the issue. No. Okay. Damn it. Yes, there's a read-write on that. Oh, this doesn't do an indirect properly. That could be a problem. Oh wait, sorry. Global buffer goes there. This one is to sync on the indirect buffer, where the indirects come from. So maybe this was setting this value. Oh, I need to do read only on the global. Okay, I think I see what's going on. So potentially this wasn't being launched enough. But then the or launched too many times. No, probably just not enough. And maybe the sync code wasn't something about that sync code. Give that a go. Right, we're still getting the glitches. Damn it. The craziest thing is it is before. I think it's on the same line you expand to that frame. But it happens like on that line before before or after. So it's on the left hand side at the top and the right hand side at the bottom. Because that's after when you talk about tile indices. They scan across the x-axis first. So why are those getting spheres? Because that would be dangerous. And that probably causes GPU crashes. I guess are we synchronizing properly? Yeah, on the global. Got that fine. So it means that the valid is something. It's really weird because it's as if. But the crazy thing as well, if I can. So let's imagine if we moved it up and enabled these ones over here. It must mean that these are valid so it can actually draw the blue. But then the ones afterwards end up not being valid. Because if not... it's either they're not valid or their start indices just happen to be correct. You know what, maybe we can debug render a valid range instead. Yeah, why don't we debug render a valid range, and that'll just be a better thing to do. So we'll just say, hey, if I'm valid, let's put blue on the screen, please. That's the valid range. Why does it never... It goes to the end of the screen. Which is fine. Oh, shoot. Right, whoops. I've just realized what's going on now. It's arranging indices. Right. Yeah, it needs to be a valid range in 2 dimensions, not 1 dimension. Because it's just wrapping around the end, doesn't it? Cool. We can do that then. Valid bottom left, top right. I guess that's what we'll change to. So bottom left, top right. We'll do a of that. Gotta get x2 there. There you go. Times 2. Right. It wraps weirdly. Starts fine. But you should be able to see blue on the right, not the left. Yeah, it's because the Y is flipped, I think. I don't know why the X is flipped. Yeah, it did, didn't it? It went off to the left. It was strange. That is sure. And hey there, Osmosko. So we actually need to turn it into... we actually need to turn it into... take the index... so I guess just mod and all that stuff. This one. Do I do it somewhere here, like a modern div? Probably not. No, that's right. Right, so you want to do like a... So your X would be mod, and your Y be div. And then also it's like a +1 thing that I kind of just accidentally did do. It needs to be .x's as well, or Y. Right, so that'd be a repeat, but instead it would be a top writer. And then this here would be ones. And then this here would be fine. Right. Good, so we've got a range, better range now, I think. So instead it's going to be a little bit more involved with the conditions. Tile coordinate dot x. So you have to do that again. Yeah, this is just going to get a bit messy, but it's okay. So y, 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 y. So you got that, which is cool. Now you've kind of want to know if this is valid to, you know what? Yeah, I wanted to render it blue, didn't I? Let's try the blue thing first, and then we'll fix this guy. Ooh. Cool, so let's see if we see any blue. We don't see any blue. That's not good. Oh, I thought it's an atomic max, damn it. Right, have a good night, Pierre. Cheers for popping by. And yeah, I guess I'll speak to you tomorrow, probably. Hmm. Okay. This seems wrong. Did I not flip the... No, 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 no. This is no longer going to work. Because the range of tiles could span differently across 1 dimensions and 2 dimensions. So it's as if you want to compute... Ah, damn it. Hmm. Yeah. Yeah, there's something to do with the... Hmm. Yeah, I think what I want to do is change how this works, maybe. Like... Maybe... Hmm. Maybe we don't have this valid thing anymore. Maybe we should actually just derive that from the fact whether this value is... We should always make this valid, basically. I think is the idea. Be the idea. Right. I think I'm getting kind of tired now. But I'll probably just find someone to raid in a minute. In most C++, you only fundamental... The only fundamental types are char, answer char. Yeah, yeah, yeah. And... Hmm. Uh... Yeah. And ball, I guess. I guess that's not fundamental types, it's an unsigned char. But yeah, it's all of those. There are new ones in C23. There's... They've also got... C23's got decimal floating point types and some other things too. But yeah, if you're talking about fundamentally, like, as a sort of bitwise bit as a bit compatible fundamental types, if you will. Sorry, distinct bit-sized fundamental types, however you want to say it. Those are them, yes, I guess. But they've got a bunch of other... They've probably got a few little ones, like enum as well. Yeah, enum floats. Yeah. Regular floats. Regular floats. So, yeah, in the next stream, we'll just obviously continue all this work and get the tile binning working great, and see get the anti-aliasing working as well correctly, and see how much of a performance gain we got, because it's 2 milliseconds on the sphere ray tracer, 5 milliseconds in total. We've got to see if we beat that and see if this is an improved way of doing it. Right, I might just bail because I'm getting tired. Right, have a good start work week, everyone. I'll see you all in a future one. Tuesday, Thursday. There's a timetable on Twitch, so you check that out and see the exact times.